Greetings and welcome to Potentials. We have a very interesting subject today. It's going to be exciting. Thank you, Ed Kabursky, for returning. We are going to be talking about superconductivity and modern alchemy. Uh, and Ed will be sharing what that's going to be about, because this is something he's been wanting to share for a very long time. And thank you for coming on Potentials.
Yeah, thanks for having me on again, Ligia. This is something that I've been wanting to share for quite a long time. It's uh, it's a transcript from a lecture that was given in Portland, Oregon, on July 28th of 1995, and it was done by David Hudson. And David Hudson actually has, in 1988, he ended up getting the patents for ORME, which are orbital rearranged monoatomic elements. So, we talked about monoatomic gold before, Lija. This is um, not necessarily where it came from, but this is information that shows sort of how they got to that point. Because there's
Hmm.
monoatomic gold, there's platinum, there's other metals essentially that all come out of this patent. And the gentleman's name is David Hudson.
Yes.
And the interesting thing here too is I think it was back at the beginning or the end of the 80s, beginning of the 90s, kind of. He worked with Hal Puthoff, and now Hal is quite famous for remote viewing and whatnot. And but he worked directly with him, and we're going to talk a little bit about that. And of course, Dave Rossi in our group knows Hal. He's
Right.
friends with him. He said so. It's kind of an interesting fact. So yeah, let's get into it.
Yes, let's get started. Hold on 1 second. Let me share the screen. And here we go. So it's superconductivity and modern alchemy. Has the philosopher's stone been found?
Yeah,
Should I keep going?
yeah. Just carry on. I might
Okay.
jump in every now and again, but just carry on. Don't mind
Okay.
me.
All right. My name is David Hudson. Well, my name isn't, but obviously his name is David Hudson. He's a third generation native Phoenician. Interesting. From an old family in the Phoenix area. We are an old family. We are very conservative. I come from an ultra conservative right wing background. I had no concept that I would ever be doing what I'm doing now when I began this work. In 1975 to 1976, I was very unhappy with the banking system here in the United States. I was farming about 70,000 acres in the Phoenix area in the Yuma Valley. It was a very large materialistic I was a very large materialistic person. I was farming this amount of ground. In
Yeah,
1975, I was doing an analysis of natural products here in the area where I was farming. You have to understand that in agriculture in the state of Arizona, we have a problem with sodium soil. Water will not penetrate the soil. Water will not leach the sodium out of the ground. It's called black alkali. What we were doing was going to the copper mines in the state of Arizona and buying 93% sulfuric acid. We were bringing the truck and trailer loads of this sulfuric acid to my farm, and I was injecting 30 tons to the acre into the soil. Wow. What I did was convert the black alkali to white alkali, which was water soluble. So within a year and a half to 2 years, you would have a field that could actually grow crops. That's amazing.
yeah. So he's got problems with the soil, and he's just trying to find a way to, farm better, I guess. And so this was not meant to the way the circumstances all happened. It was sort of pretty amazing because he wasn't going after what he was eventually found. He was just trying to help himself with
Right.
this eventually,
Yeah, he's
right?
just trying to farm.
Yeah,
Interesting.
just
Yeah.
trying to make a buck, right?
Yeah. With farming, which is not easy. It's very important when you are putting all of these amendments on your soil that you understand what is in your soil, how much iron is there, how much calcium is there, and so on. I'm doing the analysis of these natural products. We were coming across materials, in doing, uh, the analysis of these natural products, we were coming across the materials that no one seemed to be able to tell us what they were. We began to trace this material and we found that it seemed to come from a specific geological feature. Whatever the problem with this material was, we felt that the area where it was in greatest abundance would be the best place to study it. We took the material into chemistry and we dissolved it and got a solution that would be blood red. Yet when we precipitated this material out chemically by using a reductant of powdered zinc in the material would come out as black precipitant, just like it was supposed to be if it were a noble element. A noble element, if you chemically bring it out of the acid, it won't redissolve in the acid. So we precipitated this material out of the black and we took the material and dried it. In the drying process, we took a large porcelain funnel called a butiner funnel, about this big. It had a filter paper on it. This material was about a quarter of an inch thick on top of the filter paper. At the time, I didn't have a drying furnace or a drying oven, so I just set it out in the Arizona sunshine, which was about 115 degrees at 5% humidity, so it dried really fast. What happened was that after the material dried, it exploded. It exploded like no explosion I had ever heard or seen in my life. And I've worked with a lot of explosive materials. There was no explosion. There was no explosion and there was no implosion. It was as if somebody had detonated about 50,000 flash bulbs all at one time, just poof. All the material was gone. The filter paper was gone and the funnel was cracked.
Wow, right?
Yeah, yeah. Whatever this stuff is wild. We found out that that if we dried it out of the sunlight, it didn't explode. But if we dried it in the sunlight, it exploded. So then we took some of the powder that was dried out of the sunlight and we decided we were going to put it in what is called a crucible reduction. A crucible reduction involves a crucible, which is like a big drinking glass made out of porcelain. And if you mix your powder with lead and all this flux and all you heat it till the lead melts. What happens is the metals that are heavier than lead stay in the lead, and all of those that are lighter float out. This is the basic premise of your fire assays, which have been done for hundreds of years. Now, supposedly gold and silver will stay in the lead, and all your other non-heavy metals will come out of the lead. This is the tried and true way of doing metal analysis. Well, this material settled into the bottom of the lead just like it was gold and silver. This material seemed to be denser than lead. When we poured off the slag, it would take everything but the noble elements. When we poured off the lead and this material came off as a consistency at the bottom of the molten lead, it was separated from it. Yet when you take this material and put it on a bone ash couple, the lead soaks into the couple and it leaves your bead of gold and silver. Well, we did this and we got a bead that should have been gold and silver. We took this bead for analysis to all the commercial laboratories and they said, Dave, there is nothing but gold and silver there. Except I could take that bead and set it on a table and hit it with a hammer and it shattered like glass. There is no known alloy of gold and silver that is not soft. Gold and silver dissolve in each other perfectly, and they form solid solutions, and they are both very soft elements. And so any alloy of gold and silver, if that's all there is, going to be soft and ductile. You can
Ductile, yep.
flat you can flatten it out and make a pancake out of it. Yet this material shattered like glass. I said, something's going on here that we are not understanding. Something unusual is happening. So what we did is we took these beads of gold and silver and separated them chemically with the gold and silver out. What we had left was a whole bunch of black stuff. When I took this black stuff to the commercial laboratories, they told me that it was iron, silica, and aluminum. I said, this can't be iron, silica, and aluminum. First of all, you can't dissolve it in any acids or any bases once it is totally dry. It doesn't dissolve in fuming sulfuric acid. It doesn't dissolve in sulfuric nitric acid. It doesn't dissolve in hydrochloric nitric acid. Even if
Wow.
this dissolves gold, yet it won't dissolve this black stuff. I thought this material is really strange. It just has to be, there just has to be an explanation. No one could tell me what it was. Basically, I went to Cornell University. I said, we are just going to have to throw some money at this problem. So I went and hired PhD at Cornell, who considered himself an expert on precious elements. I suspected we were dealing with precious elements. I said, I want to know what this is. I paid him to come out to Arizona. He looked at the problem. He said, we have a machine back at Cornell that can analyze down to parts per billion. He said, you let me take this material back to Cornell and I'll tell you exactly what you have exactly. When we got back there, he told me it was iron, silica, aluminum. I said, look, doctor, do you have a chemistry laboratory around here we can borrow? He said, yes. I said, let's go to the chemistry laboratory. We worked in the chemistry laboratory all the rest of the day, and we were able to remove all the silica, all the iron, and all the aluminum. We still had 98% of the sample, and that was pure nothing. I said, look, I can hold this in my hand. I can weigh it. I can perform chemistries with it. I said, that is something. I know that is something. It is not nothing. He said, the absorption or emission spectrum does not agree with anything we have programmed into our instrument. I said, well, that is something, and I'm going to find out what. And he said, Mr. Hudson, why don't you give us $350,000 grant and we'll put graduate students into looking into it? Sir, I don't know what you pay the people around here, but we pay minimum wage on the farm where I work, and I can get a lot more out of $3,500,000 than, or $350,000 than you
Yeah.
can. So I'm going to go back and do the work myself. Smart man.
Yep. Exactly.
I came back to Phoenix totally disillusioned with academia. I was not impressed with the PhDs.
Imagine that.
Fortunately, I asked around the Phoenix area and I found out about a man who was a spectroscopist. He had been trained in West Germany in at the Institute for Spectroscopy. He
Spectroscopy.
had, yes, that. Uh,
Yep.
he had been the senior technician for a lab test company in Los Angeles, which builds spectroscopic equipment. He's the man who blueprinted them, designed them, constructed them, then took them to the field and made them work. I said, here's a good man. This is not just a technician. Here's a man who knows how the machine works.
Hmm.
I went to him with the Soviet book that the fire assay man had given me. It was called The Analytical Chemistry of the Platinum Group Elements by Ginsberg. It was published by the Soviet Academy of Sciences. In this book, according to the Soviets, you had to do a 300-second burn on these elements to read them. Now, for those of you who have never done spectroscopy, and I can't even say it, it involves taking a carbon electrode that is cupped at the top. You put the powder on that electrode and you bring the other electrode down above it and you strike an arc. In about 15 seconds, the carbon at this high temperature burns away and the electrode's gone and your sample's gone. So all the laboratories in this country are doing 15-second burns and giving you the results. According to the Soviet Academy of Sciences, the boiling temperature of water is to the boiling temperature of iron, just like the boiling temperature of iron is to the boiling temperature of these elements. So literally, we had to design and build an excitation chamber where argon gas could be put around this electrode so that no oxygen or air could get into the carbon electrode, and we could burn it not for 15 seconds, but for 300 seconds. According
Hmm.
to the Soviet Academy of Sciences, this is the length of time we have to burn the sample. We set up, we got the PK blenders, we got the standards, we modified the machine, we did all the analysis for the results. We did all the spectral lines on this 3.5-meter instrument. Anyway, when we ran this material through the first 15 seconds, we got iron, silica, aluminum, little traces of calcium, sodium, maybe a little titanium now and then, and it goes quiet and nothing reads. So at the end of 15 seconds, you're getting nothing. 20 seconds, 25 seconds, 30 seconds, 35 seconds, 40 seconds, still got nothing. 45 seconds, 50 seconds, 55 seconds, 60 seconds, 65 seconds. But if you look in through the colored glass sitting there on the carbon electrode, this little ball of white material, there's still something there. At 70 seconds, exactly when the Soviet Academy of Science said it would read, palladium begins to read. And after the palladium, platinum begins to read. And after the platinum, I think it was rhodium begins to read. After rhodium, ruthenium begins to read. After ruthenium, then iridium begins to read. And after the iridium, osmium begins to read. Now, if you're like me, I don't know what these elements were. I had heard of platinum, platinum jewelry, but what are these other elements? Well, there are 6 platinum group elements, and the periodic table, not just platinum. In the in the periodic table, sorry, not just platinum.
Yes.
They didn't find out about them at the same time, so they have been added one at a time. They are all elements just like iron, cobalt, and nickel are 3 different elements. Ruthenium, modium, and palladium are light platinums, and osmium, iridium, and platinum are the heavy platinums. Well, we came to find out that rhodium was selling for about $3,000 per ounce. Gold sells for about $400 an ounce. Iridium sells for about $800 an ounce. And ruthenium sells for $150 an ounce. Then you say, gee, these are important materials, aren't they? They are important materials because in the world, the best known deposit is now being mined in South Africa.
Hmm.
In this deposit, you have to go half a mile into the ground and mine an 18-inch seam of this stuff. When you bring it out, it contains 1/3 of 1 ounce per ton of all the precious elements. Our analysis, which we ran for 2.5 years, and we checked over and over, we checked every spectral line, we checked every potential or interference, we checked every aspect of this. We created apples and apples, oranges and oranges, bananas and bananas. We wanted exact matches. When we were finished, the man was able to do quantitative analysis, and he said, Dave, you have 6 to 8 ounces of per ton of palladium, 12 to 13 ounces per ton of platinum, 150 ounces per ton of osmium, 250 ounces per ton of ruthenium, 600 ounces per ton of iridium, and 800 ounces per ton of rhodium, or a total of about 2,400 ounces per ton when the best known deposit in the world is 1/3 of 1 ounce per ton.
Isn't that wild, right?
Yeah. As you can see, this work wasn't an indicator that these elements were there. These elements were there and they were there in buku amounts. They were saying, hey, stupid man, pay attention. We're trying to show you something. The crazy thing about it is, all we had done is remove the silica and sent the other stuff in. It was pretty unbelievable numbers. After we had come at this in every way we know how to disprove it, I decided all we have to do is throw money at this problem because money solves everything, right? So at 69 seconds, I stopped the burn. I let the machine cool down and I took a pocket knife and dug that little bead out of the top of the electrode. When you shut off the arc, it sort of absorbs down into the carbon, and you have to dig down into the carbon to get it out, this little bead of metal. So I sent this little bead of metal over to Harlow Laboratories in London. They made a precious metals analysis on this bead. I get the report back, no precious element detected. Now, this was 1 second before the palladium was supposed to start leaving. Yet, according to neutron activation, which analyzes the nucleus itself, there were no precious elements detected. This made me absolutely no sense at all. There had to be an explanation here.
Mhm.
Either this material was converted to another element, or it's in a form that we don't understand yet. So I decided that I just had to get more information on it. I went to a PhD analytical chemist, a man who was trained at separating and purifying individual elements out of unknown material. He was trained at Iowa State University and had a PhD in metal separation systems. He's the man that Motorola and Sperry used in the state of Arizona to handle their wastewater problems. Okay, interesting. Um,
Hmm.
Now, this was a big sample. We just made iron turn into silica and aluminum. The Snow White annealed sample was analyzed as calcium and silica. Where did the aluminum go? John said. Dave, my life was so simple before I met you. He said, this makes absolutely no sense at all. He said, what are you working with? What you are working with is going to cause them to rewrite physics books, to rewrite chemistry books, and to come to a complete new understanding.
Awesome.
Dave, I have separated physically and I have checked it chemically 50 different ways, and you have 4 to 6 ounces per ton of palladium, 12 to 14 ounces per ton of platinum, and 150 ounces per ton of osmium, 250 ounces per ton of ruthium, ruthenium, 600 ounces per ton of iridium, and 800 ounces per ton of osmium. The same exact numbers that the spectroscopist had told me were there. It was such an incredible number that John said, Dave, I've got to go to the natural place where this stuff comes from, and I've got to take my own samples. So we went up and actually walked the property, and he took his own samples and put it in a bag, brought them back to the laboratory, pulverized the entire sample, and then started doing the analysis on what is called the master blend sample, which represented the whole geology, and he got the same numbers. We worked on this from 1983 to 1989.
Yeah.
Though one PhD chemist, 3 master chemists, 2 technicians working full time, using the Soviet Academy of Sciences, the US Bureau of Standards, Weights and Measures information as a starting point. We literally learned how to do qualitative and quantitative separations of all of these elements. We learned how to do this with iridium. We learned how to do it with gold. We learned how to do it with osmium. We learned how to do it with ruthium. And what we found when we actually purchased a machine called high pressure liquid chromatography. And for your information, this person named John Sikapos, we don't know, was the man who actually wrote his PhD thesis at Iowa State University on how to build this instrument. He conceptualized building this instrument back in 1963 to 1964. It's computer controlled, all high pressure, and you can do very precise separations with it because this is the man who conceptualized, designed it, told them what the limitations would be eventually. On it, he was the ideal man to take the technology and perfect it. So we were able to use their basic technology and develop a separation system for taking the rhodium trichloride. We actually separated 5 different species in the commercial rhodium trichloride. What this is all about is the word metal is like the word army. You can't have a one-man army. The word metal refers to a conglomerate material. It has certain properties, electrical conductivity, heat conduction, and all these other aspects to it. When you dissolve the metals in acid, you get a solution that is clear without solids. You assume it's a free ion, but when you are dealing with noble elements, it's still not a free ion. It's still what is called cluster chemistry. Interesting. Okay.
Mhm.
When our material was sent to them to them, the rhodium as received was analyzed to not have any rhodium in it. Yet when they mounted it on carbon in their fuel cell technology and ran the fuel cell for several weeks, it worked and it did what only rhodium would do. And it was carbon monoxide stable. After 3 weeks, they shut the fuel cells down and they take the electrodes out and sent them back to the same place that said there was no rhodium in the original sample. And now there is over 8% rhodium in the rhodium. What happens is that it begins to nucleate on the carbon. It actually begins to grow metal bonds. So now there was metallic rhodium showing on the carbon where before there was no rhodium. So these GE people said, Dave, if you were the first one to discover this, if you were the first one to explain how to make it in this form. If you are the first one to tell the world that it exists, then you can get a patent on this. I said, I'm not interested in patenting this. Then they told me that if someone else discovered it and patented it, even though I was using it every day, they could stop me from doing it. I said, well, maybe I should patent it. So in March of 1988, we filed US and worldwide patents on orbitally rearranged monatomic elements. Now that is a
Yes.
mouthful. So to make it short, we called it ORMEs. You have ORME gold, ORME palladium, ORME iridium, ORME ruthenium, ORME osmium, and ORMEs.
Yep.
When we were doing this patent procedure, the patent office said, Dave, we need more precise data. We need more exact data, and we need more information about this conversion to this white powder state. So one of the problems we had is when you make this white powder and you bring it out into the atmosphere, it starts gaining weight. It really starts gaining weight. Um, I'm not talking about a little bit of weight. I'm talking about 20 to 30%. This is not explained elsewhere. What does it mean? Now that normally would be called absorption of atmospheric gases. The air is reacting with it and causing weight gain, but not 20 or 30%.
Mhm.
We had to come up with the exact data for the patent office. So what we did was use this machine called thermogravimetric analysis. This is a
Mhm.
machine that has total atmospheric control of the sample. You can oxidize it, hydro reduce it, and anneal it while continually weighing the sample under a controlled atmosphere. We heated the material at 1.2 degrees per minute and cooled it at 2 degrees per minute. What we found is when you oxidize the material, it weighs 102%. When you hydro reduce it, it weighs 103%. So far, so good, no problem. But when it turns snow white, it weighs 56%. Now
Mhm.
that's impossible.
Yep.
When you anneal it and it turns white, it only weighs 56% of the beginning weight. If you put that on a silica test boat and you weigh it, it weighs 56%. If you heat it to the point that it fuses into the glass, it turns black and all the weight returns. So the material hadn't volatilized away. It was still there. It just couldn't be weighed anymore. That's when everyone said, this just isn't right. It can't be. Do you know that when we heated it and cooled it and heated it and cooled it and heated it and cooled it under helium or argon, that when we cooled it, it would weigh 3 to 400% of its beginning weight. And when we heated it, it would actually weigh less than nothing. If it wasn't in the pan, and the pan would weigh more than the pan weighs when the stuff it is in it.
Crazy, right?
That is wild.
Yep.
So yet when our material is put in there in it and it turns white, it goes to 56% of its beginning weight. If you shut the machine off and let it cool, it is exactly 56%. If you heated it, it would go less than nothing. And if you cooled it, it would go 3 to 400%. But it always goes back to a steady 56%. Now we contacted Bree in the Bay Area and we said, look, this just doesn't make any sense. There's something wrong with this machine. I mean, something isn't right. Every time we use the machine, it works fine unless we make the pure monatomic material. And when we do it, it turns snow white and it doesn't work correctly anymore. And Brian looked over our results and said, you know, Mr. Hudson, if you were working with the cooling of the material, we would say it is superconducting. But inasmuch as you are
Mhm.
heating the material, we don't know what you've got. I decided, well, I have to learn chemistry and I have to learn physics. And now I've got to learn the physics of superconductors. So I borrowed a bunch of graduate books on superconductivity and I began to read about superconductors. One thing we did is we took our white powder. Now, if this is a superconductor, we should be able to put this white powder down on the table. We should be able to hook up a voltmeter here to it. You know, your voltmeter has got two electrodes. And if you put it on a wire and turn on the battery pack, and it tells you the resistance in the wire. So what we found is that the definition of a superconductor is that it does not allow any voltage potential or any magnetic field to exist inside the sample. So by definition, a superconductor will not allow any voltage potential to exist inside the sample. To get electricity off of a wire requires voltage, and to get electricity back on the wire requires a voltage. So it cannot receive electricity from a wire. It cannot receive the energy of the superconductor back on the wire without voltage. Well, what you come to find out is that in the superconductor, there is a single frequency of light, just like a laser, that is flowing perpetually inside the superconductor. And when it flows inside the superconductor, it produces around it what is called a Meissner field, which is unique to superconductors. A Meissner
Hmm.
field excludes all external magnetic fields from the sample. What color must it be? It has to be white. Anything that excludes all light from the sample has to be white. Anything that absorbs all the light has to be black. That's absolutely true. I know that as an artist.
Hmm.
How does this statement square with the flash in the pan from exposure to sunlight? It ref it all ref it If it reflects all light, it has to be white. Now, I am talking about a pure single element superconductor. It has to be white when it is superconducting. I'm going to take a sip of my water here.
Hmm.
What you have to do is you have to take a radio frequency transmitter and you have to resonance frequency tune the superconductor to match the frequency of the wire,
Hmm.
or likely tune the wire to match the superconductor. So the wire now is in oscillation with its electron waves exactly the same as the superconductor. At that point, the electronic pair can go on the superconductor with no push at all because electrons are continually moving over here on the wire and they are seeking the path of least resistance. And so when you have them in perfect synchronization with the superconductor, they go on with no push at all as pairs. And now this takes a little explaining because one spin, one half electron plus one spin, one half electron are two particles. Yet when these two particles become perfectly paired as mirror images of each other, they lose all particle aspects and they become nothing but pure light. This doesn't make sense either, does it? But that's the way it is. Spin one half plus spin one half gives you a spin one, which is now pure light. Trust
Hmm.
me, it is so. So they can't go on as individual electrons, they go on as light. Now, the crazy thing about electrons is that one electron can exist in one spacetime, and if it moves to another spacetime, it gives off light or absorbs light. It's moving from one spacetime to another. Now we have light, which is two electrons. Light doesn't exist in any spacetime. You can put 100 billion lights all in the same in the same spacetime, and it is okay. Now we don't have a conductor. A conductor, you put electricity on the wire. You got to take the electricity off or it won't flow. You got to ground it, right? With a superconductor, it's not. It can go on and on and on and on. It doesn't have to come off. Now, if you want to take it off, you have to put a wire next to it and you have to resonance frequency tune the wire to match the superconductor. And when it's in perfect harmony, you apply a voltage and poof, off goes the electricity.
Hmm.
So if you literally can make a superconductor that stretches from Portland to New York City, and you put energy over here for 2 or 3 or 4 days, you don't have to take it off over there. It's okay. You can keep putting it in. And when they want it in New York, they can resonance frequency tune the wire, apply voltage, and suck it out. It gets a free ride from Portland all the way to New York on this quantum wave of the superconductor as light, not electricity. That's amazing. How do
Cool,
you
eh?
feature, how do you measure it if it has no voltage in it? How is it possible to get a machine that can measure this light? And guess what? It can't be done because every piece of instrumentation man has ever figured out always uses a differential. It must reflect, and yet a superconductor has no voltage. You literally start the superconductor flowing by applying a magnetic field. It responds to the magnetic field by flowing light inside of it and building a bigger Meissner field around it. You can put your magnet down and walk away. You can come back 100 years later and it is still flowing exactly the same as when you left it.
Mm-hmm.
It doesn't ever slow down. It excludes not 99.9999. It excludes 100.0000 or all external magnetic fields. There is absolutely no resistance in the sample. It is perpetual motion. It runs forever and ever and ever and ever. I love that. That's awesome.
Mm-hmm.
The
Cool.
Russian physicist Sakharov said in the 1960s that we are looking for gravity and we are never going to find it as a magnetic field.
Mm-hmm.
Gravity is what is produced when protons, neutrons, and electrons interact with the vacuum energy. That energy is everywhere in the universe, timeless. That energy that is there like the ether, like I call it ether energy.
Yep.
When you pump out all heat and all matter, everything, there is still energy there. It's called the vacuum energy. When the protons, neutrons, and electrons interact with that energy, they produce gravity. If there is no matter, there is no gravity. Interesting theory.
Mm.
Everyone kind of ignored it for a while. Then this fellow by the name of Hal Puthoff, my man, I love you, down in Texas, who began life over here in the Bay Area in California, doing distance viewing experimentation. Now he's working down in Austin, Texas. Hal Puthoff works at the Institute for Advanced Studies in Austin at Austin in Austin, Texas. And he actually developed the mathematics for Sakharov's theory of gravity. He published this in 1993 in one of the top science journals. It was actually published in March 1st, 1989 issue of Physical Review A. The paper is titled Gravity as a Zero-Point Fluctuation Force by H.E. Puthoff.
Yeah.
In the mathematics, he actually does all his mathematical calculations. It figures out that when matter begins to react in 2 dimensions as opposed to interacting in 3 dimensions, which by definition, a superconductor is a resonance coupled quantum oscillator resonating in 2 dimensions, not 3 dimensions. He comes up with the mathematics which shows when it begins to interact in 2 dimensions that it should theoretically lose 4/9 of its gravitational weight.
Mm.
Did you know that 5/9 is 56% exactly?
Interesting, right?
So I decided that I've got to go down and see Hal Puthoff. I've got to take all my data and go down and see Hal Puthoff. Yep. I said, Hal, we have the experimental confirmation that, in fact, your mathematics are absolutely correct. In addition, Sakharov's theory of gravity is absolutely correct because this material only weighs 56% when it goes to the superconducting state. And Hal Puthoff says, Dave, do you realize that gravity is what determines space-time?
Mm. Interesting.
Whoa,
Yep.
that's pretty deep. And he said, Dave, when this material only weighs 56% of its true mass, you do realize that this material is actually bending space-time. That's so cool. Now, if you think about this, it seems correct. He said, Dave, what we really need is a material that totally bends space-time, a material that has no gravitational attraction at all, less than zero. It's what he called exotic matter in his papers. I said, Hal, do you realize that if you heat this material, it has no gravitational attraction at all? I've been reading papers on the vacuum energy. Do you know that there is an overlap between the thermal spectrum and the 0-point spectrum? The two of them overlap. And so if you heat something, it should interact with the 0-point energy. Well, this material, because it was resonating in 2 dimensions, when you heat it, it literally loses all gravitational attraction. You know what Hal Puthoff said to me? He said, Dave, at that point, you shouldn't be able to see the material.
Mm-hmm.
I said, correct. You can look in the pan, through the quartz tube, and there is nothing in the pan. But the pan isn't weighing what it would weigh if the stuff wasn't in it.
Yeah.
Now, I had mistakenly assumed that the material was just resonating at a frequency we didn't perceive. He said, Dave, theoretically, it should be withdrawing from these three dimensions. It should not even be in these three dimensions. I said, wow. He said, Dave, you have to devise an experiment where you can do this. While it is not there, pass an arm through the sample pan. So if it is there and resonating at a frequency that you don't perceive, you knock it out of the pan. Ooh. Because when you cool it back down and it begins to reappear, it always appears in the same shape it was before it left. And he says, if it's there, you're going to knock it out of the pan. And then when you cool it down, it's going to return back in exactly the place it was before. That's proof that it left these three dimensions. And he said, Dave, if you do that, you will never, ever want for money. Do you think a stealth plane is really important? What happens when it can literally disappear?
Hmm.
Now, what are some of these other aspects? What are some of the other aspects of superconductor? You see, in 1988, I not only filed a patent on ORMs, or however you say that, I filed a patents on S-ORMs, the resonant coupled quantum oscillating system of many atoms of these ORMs. I have 11 patents on ORMs and another 11 patents on S-ORMs. I have 22 patents. What are some of the other aspects of a superconductor? A superconductor, how do you prove it's a superconductor? You literally take a constant magnetic field and you pass the material into the constant magnetic field. If it's not a superconductor, if you apply a magnetic field, you get a positive inductance. If it's a superconductor, as you apply a magnetic field, it goes negative. It literally eats the magnetic field. It feeds on the magnetic field and it takes it inside itself. Negative inductance in a positive applied magnetic field is the proof of a superconductor. In other
Hmm.
words, if you had a machine that was a superconductor, when it passed by ordinary power lines, it would cancel the voltage potential of the power lines. Or if it passed by a home that had an electric appliance or electric appliances, it would literally turn them off and cause them to flicker and go off. Do you realize that if you had a machine that would do that, it could literally move space-time, is what Hal was saying?
Wow, right?
Wow, that's wild. That it could disappear and reappear in time-space. It could withdraw from these three dimensions into a fifth dimension where there is no distance and there is no time between here and other star systems, and then reappear out of that in a star system. Have you ever heard of anything else that does that? Anyway, the material is very, very important. The material and the way it works is very, very important because what we are talking about, controlling gravity, and we are talking about controlling space-time. A
Wow.
superconductor is billions and billions and billions of atoms, all acting like one big macro atom. And so literally you make yourself a vessel that you can climb inside of that superconducts and you energize it and you exclude all external magnetic fields, including gravity. You would just have pure awareness. And that is correct, Dave says.
Hmm.
Dave Hudson recovers by saying that is correct. I'm recovering from this. This is pretty wow.
I told you.
Mm.
Yeah.
Mind blowing, like, woo, my mind is like pulsing right now.
Hmm.
Uh, 5% by dry matter weight of the brain tissue is rhodium, and iridium is in the high spin state. Oh, did you know that over 5% by dry matter weight of the brain tissue is rhodium, and iridium is the high spin state? Whoa. Okay. Did you know that the way cells communicate with each other is by superconductivity?
Hmm.
That the U.S. Naval Research Facility knows that the way cells communicate with each other is by superconductivity, that they have actually measured it using squids, superconducting quantum interference devices with a superconducting ring around the body. And they have seen this by procedure that literally light flowed between cell to cell to cell to cell. Did you know
Cool.
that your nerve impulses are not electricity, that they travel closer to the speed of sound than they do the speed of light, and electricity travels closer to the speed of light. Do you know what speed the superconducting wave travels? We will find out. The speed of sound.
Mhm. Yeah.
This, in fact, is what your body is in your body that we call the consciousness. It's
Wow.
what separates you from a computer.
Wow. Big
Interesting.
statement.
Yes. Wow. That's really heavy.
Hmm.
Um, okay. It literally is the light of life. This is the part of your body that has been there all this time that scientists can't find because their instruments can't see it. Uh, there are 11 elements that it could be, but primarily rhodium and iridium are the elements that are in your body right now, and that literally they they resonance connect and literally flow the light of life perpetually in your body. And around your body, you have a nonpolar magnetic field, which is called the Meissner field, or they refer to it as the aura or
Wow.
biofield. Yep.
Yeah.
That literally, these are the spirit atoms in your body. These are the atoms that are in resonant harmony and resonating with the vacuum energy or the ether. And the vacuum energy is another dimension where there is no time. Everything that ever existed and everything that ever will exist is registered in the vacuum. And I will tell you now, my friends, that when you meet your God, you will meet him in the vacuum.
That's awesome.
Yes.
Yep.
That is where all matter came from, and that is where all matter originated, and that is where everything is recorded. And your
Hmm.
connection is through these resonant oscillators that are in quantum resonance with the vacuum energy. That is what brings the light of life from the world of the quanta up to the macro body you call your own physical being. These atoms with the macro state android look like a white powder, but actually, if you look at them under a microscope, they look like glass. You can actually heat the white powder to 1160 degrees under a vacuum, and it forms a glass just like that window glass, another form the element can exist in. When you come to understand that each of these atoms is resonating within the vacuum with the vacuum energy, you can't harness a single atom. You can't put reins on it and say, work for me, this perpetual motion machine. But when one atom is resonating back and forth in two dimensions, it creates a quantile wave that comes off of it. The next atom nestles in that wave and perpetuates the wave. Excuse me, I have to. The atoms are actually too far apart to have any chemistry, and yet they are sitting at a distance, resonating in perfect unison, harmony. The energy that literally rolls around one atom forever and ever and ever. Did you ever ask yourself why an atom never runs down? It is because it is dipping into the 0 point energy all of the time.
Yeah.
But now you have each atom in resonant harmony with each other, each atom dipping into the 0 point energy. So now you've got billions and billions and billions of them doing it for you. So what you now have is a perpetual motion machine. You have something that is literally running perpetually on 0 point energy. Gosh,
Yeah.
literally when you think it registers. So when you are working with this material, your thoughts are registering in the material.
Wow.
Yes. Ooh. So, and what we also found is that there was an amplification of heat about 2000 times. It was not chemical heat, it was nuclear heat. Uh, and what you have to do is give them the chemistries what they want. Cooperate with them, coerce them, give them what they want, and they will literally go back to the low spin state. And you can make them into metals, or you can use them in the high spin state. Now, everything was pretty interesting now until my uncle came up with this book in 1991 called The Secrets of the Alchemists. I said, I'm not
Mhm.
interested in reading about alchemy. This is when the church was involved in it and everything. It was all very perverted. I'm not interested in that. I want to know about chemistry and physics. He said, Dave, it talks about a white powder of gold. I said,
Mm.
really? And so I began to look into alchemy and the philosopher's stone. The container of the light of life was the white powder of gold. Now I
Mhm.
said, is there a chance that this is the white powder of gold that I have? Could it be the white powder of gold they're talking about? Or is it possible that there is two white powders of gold? Now, the description says it is in the container of the essence of life. It flows the light of life. Well, that we have proven. It is a superconductor. It flows the light that is in your body. They claimed that it perfects the cells of the body.
Mhm.
Well, I can show you tomorrow Bristol Myers Squibb research that shows that this material interacts with DNA, correcting the DNA. All this carcinogenic damage, all the radiation damage, all is corrected from these elements in the presence of the cell. They don't chemically interact with it. They just correct the DNA. I really became intrigued with this stuff. What will happen if we give this material to people? It's not metal-metal bonding, so it doesn't have the heavy metal properties. So first of all, we've got a golden retriever, and we gave the material to the golden retriever. The golden retriever had tick fever, valley fever, had a large abscess there on his side, here on his side, and none of the veterinarians could find any medicine that would get rid of it due to the combination of all three diseases. They just gave up. They weren't going to cure him. We began giving him 1 cc injections of 1 milligram of white powder. One shot the tumor and one shot in the bloodstream. One shot in the tumor, one shot in the bloodstream. After a week and a half, the tick fever was gone. The valley fever was gone. The tumor had shrunk down and disappeared. So we stopped the injections. About a week later, it starts coming back again. So we started giving the injections again, and it shrunk back down again. This time we continued about a week longer than when we had stopped, and it never came back. The dog felt great. So then the doctor we were working with said, this is really incredible stuff. He said, I have been an assistant that works in my doctor's office who is a day or two away from death with AIDS. He is being fed intravenously right now. He can't speak, he can't dress himself, he's dying. So he said, I'm going to start giving him just a little bit of this material to see what happens. A week and a half later, he had pulled out all of the feed lines of his arms. He was feeding himself normally, getting dressed on his own, just doing great. A month and a half later, he was on an airplane going back to a family wedding in Indiana, and nobody even knows he has AIDS. The doctor says, Dave, this is like a magic material. So he got a patent, and we began to give him 1 milliliter injections into his bloodstream, 1 milligram per day. So, uh, just reading what's highlighted. Um, so 5 milligrams per day orally, 100 milligrams for a month and a half. Uh, this is pro-life. It is literally the spirit. This material is, in fact, a philosophical material. It is here to enlighten and to raise the consciousness of mankind. If in doing that it happens to cure disease, so be it. It's real hard for most of us to understand that this is what it is all about. And I don't know. That's it. Yep.
Yeah.
So
And
wow.
I know, right? It's there's a lot there. Um, but it's well worth looking into if other people want to research it further. David Hudson is the person to look for. But this was a transcript that came from Nexus magazine in November of 1996, but it was of him, doing the thing in Portland, Oregon. And to now, I actually don't know what's become of David Hudson. Um,
I was just going to ask if he's still around,
yeah,
but you don't
and
know.
we could probably find out through Hal, perhaps, because maybe Dave could ask Hal if he knows whatever
Right.
happened to David Hudson, because this is truly incredible. And I know people that have do take uh, white gold or monoatomic gold, and it does definitely help your health. There's no question about that, right?
Absolutely. Yes.
Yeah.
Yes, yes. Um, yeah, there's a lot of people out there making it too. And so it's interesting. I'm curious if David Hudson ever made it and manufactured it and sold it? Because this
Um,
paper doesn't say whether he did that or not.
I I think so, but I'm not 100% sure, and it's is something that we should probably check into and find out more about. And I would suggest that when people buy it, they really want to make sure that it's actually coming from his patents. So it's the real
Right.
McCoy,
Right.
essentially, right?
Because
Because
there's a
we
lot of
know,
people out there doing that. They're making it and saying that's what it is, and it isn't really the real
yeah,
stuff.
yeah,
And
or it's not being made with the process that he uses according to the
right,
patents,
exactly,
so
yeah.
yeah, and so that's something, if anybody's going to look into these types of things, that they should really dive into before they start paying money for
Yeah,
example, right? Yeah, but
exactly.
but yeah, tremendous information, and it does show you that um, there is modern alchemy, and there is definitely superconductivity, and there are room temperature superconductors. I actually know of a technology that was developed for the passive sonar system of nuclear submarines that uses this type of technology. So it's out there, and it's worthwhile if people want to do a deep dive to check into it all for sure. Yeah.
Yeah, I think it's something that's going to be coming out a lot more in the future, within the next few years. I think we're going to be seeing a lot more about superconductivity and
Oh,
superconductors. Yeah,
yeah, absolutely. Now, some of the there is superconductivity coming out of the Pius patents, and that uses graphene. But there are other elements, because that's not, he never talked about graphene at all in
right. He
here.
didn't mention that in these. Right.
Yeah, yeah. So there are other ways of doing it as well. So that's just something to keep in mind for
So
everyone
there's
for
a
sure.
lot of different types of superconductors out there. Like if you do a search for superconductors on Google, you do a Google search, you're going to find so many different types.
Yeah,
Um,
but
and I
but
would,
sorry, but what I was going to say was most of them require low temperatures to
mhm.
become
Right.
active superconductors, where
Yes.
what we're starting to talk about more is room temperature superconductors
Right.
and the types of materials and the technologies involved with that. Because ultimately, even at Stavati, I would imagine at some point the hull of the ships are going to have room temperature superconductors on them to make them more efficient, perhaps. It might be
Right.
something that we could ask Chris actually,
Oh,
if that's
yeah.
the case,
Also,
right?
if you want to do research on the room temperature superconductors, I would recommend using Yandex instead of Google, because you'll
Yes,
probably find a lot more information on it on that
yeah,
browser instead. So,
yeah. And if people want to dive into it a little bit more, with the room temperature superconductor technology that is used with the nuclear submarine sonar systems, then Dr. Jack Bybee, PhD Dr. Jack Bybee, and what ended up happening was when they went from diesel submarines to nuclear ones, they were a lot quieter. So then they wanted to max out the sonar systems on them. So they increased and did the electronic side of everything as best they could, but then they still wanted more performance. So then they, what they're called are quantum purifiers, these room temperature superconductor technologies, and they actually work on the ground side of electronics. So they don't work within the electronics themselves. They work from the ground side.
right.
And I've had a pair of them for about 25 years now that I've been experimenting with, that I've shown, I've shown them
Oh,
to you and a few other
right.
people.
Right.
Um,
Right.
right. So it is technology out there, but yeah, Dr. Jack Bybee, and it's Bybee, Bybee is who to
Right.
sort of search, and quantum purifiers is what they're called.
Right. I
Yeah.
can also try to put that link in the bottom so people
Yeah,
can look it up.
yeah,
Yeah.
that would be wonderful. So
Yeah.
it's been great to be with you again. This one was wild, like I said. There's so much to unpack here. Plus the material, I mean, it was going invisible.
Yeah.
It was losing weight.
Hmm.
So there's much, much more going on here than meets the eye, literally,
Right.
so to speak, right? Yeah,
Exactly. Yeah. And there
yeah,
was perpetual motion coming, that as a result. There were people that were getting healed as a result. So there's so many different applications it can be used for. It's amazing,
Yeah,
truly
yeah.
amazing. So,
And white gold or white powder does show up in Egypt, in
yeah,
other places in the world where they've gone into chambers in uh, Bujeti Mountains, I think it's called. In They went into a chamber, and that's where there's a sphinx there as well. There's also a sphinx there. I'm just trying to remember the country. I can't remember right now.
I
Um,
can't think of it
but
either.
it's the Bujeti Mountains, and they went into a chamber, and on top of the chamber there was a whole pile of white powder, which probably ended up being white gold
Mm,
or monoatomic gold essentially. So
right.
the ancients had this a long time ago,
Oh, yeah.
right? It's something that David Hudson, he's got patents on it, but the technology was from a very long time ago.
Yeah.
So I'm trying to
Well, he
say,
sort of
right?
just stumbled across it, and it's like
Yeah,
humans, I guess we just, keep stumbling across things, but it's just interesting the timing, of
yeah,
when things happen,
yeah, yeah, and
So,
him ending up working with Hal too, which is kind
yeah.
of interesting, right?
Yeah. Right.
Because Hal is known for remote viewing now more than anything, not this type of thing, right?
Right, with the Stanford Institute and working with Ingo Swann and all of that kind of thing, but people don't
Yeah,
realize what other things he's done and what else he's accomplished. Yeah.
yeah, yeah,
So,
definitely. Yeah, yeah. So very cool. Well, thanks again.
yes, thank you. Thank you for coming back and sharing all of this wonderful information with us. And it's really, really heavy. Something that I hope people will, do a little bit more of their own research and, look into for themselves and maybe, figure out how to have this so that more people can actually have the ability to use this information, to
Yeah,
help other people, to help the
the
world in general. That's
yeah
that's what
the benefits to
I'm hoping.
mankind with this information and the materials and this stuff is really tremendous. So that's why we're
Absolutely.
bringing it
Think,
to you now, essentially, right?
think about how many people could be healed from this. If it healed that one guy with AIDS, how many other people could it heal? People with cancer, people with all kinds of,
Yeah,
problems. The animals, your pets could be healed. It's amazing.
yeah,
Um, yeah. So I hope everybody enjoyed this episode, and we definitely did. I'm very, very grateful to be able to bring this to you, and I hope that everybody will come back again for the next one. Uh, Thank you for your support. I love you, and ciao for now.